So in this video, we're going to take a look at similar triangles in action in an exam paper question. So the question is talking about a cone. It's a disposable paper cup. It's in the shape of an inverted right circular cone. As shown, the height of the paper cup is 80 millimeters and the diameter is 50. So what I'm going to do for myself straight away to help me is I'm going to mark in those measurements because they haven't done that. So the full height of it is 80. Then going across, I'm going to have 50, but if it's 50 the full way across, then don't I know that the radius, the full radius when the cup is completely full, I know that that's 25. And the next thing then they say is that the cup is filled with water to a depth of h. However, the cup is leaking from its vertex at a rate of 8 millimeters cubed per second. Okay, given that that r is the radius of the free surface of the water in the paper cup when the depth is h, express h in terms of r. So you might be looking at that going, well, geez, there's no real connection between the two there. What can I do? And this is where the similar triangle comes in, because what you have is when the cup is completely full, you have a triangle that has a side of 25 there. You've got a right angle coming down here, and you've got this to be 80, and then it's got its slant height, which we don't need to know in this instance. But what we do know is that that's a right angle there, and then this angle down here is this angle here. Okay, if I look at what I'm trying to do, which is the height h, which is how far up it goes, up as far as here, so that's that height up to there, so it's a little bit shorter, and I want to talk about the radius going across here. Well, there's the triangle again, and it's a right angle triangle once more. And we also, if we look at that shape that I've just drawn out, it's the same angle. So if I draw that line up there, look, that angle in there is the exact same as this one that I've marked in here. So straight away, I do actually have similar triangles, because with similar triangles, you need three angles to be the same and you need them to be orientated in the same way for this to line up. And we have that. If two of the angles are the same, by default, the third has to be the same. So what I'm going to be able to say, because they're similar, is that the ratio of them is the same. So what I'm going to say is that's the h there. I know that basically all a similar triangle is I've either zoomed in or zoomed out on the same triangle, and I've changed just the values, but the ratio, so the comparison of r to h, is going to be the same ratio. And the same in maths means that they're equal. So I'm going to say that 25 divided by 80, that ratio in the big triangle is equal to, because they are similar, it's equal to the height. So match up the sides. The height is on the bottom, and then your r is on the top, which is your the radius. Now I need to get r h on its own, so I'm going to rearrange this, and if I multiply up by h, multiply up by 80 and divide by 25, what I'm going to get here is h is equal to r, and then it's going to be 80r over 25, which I can simplify down to be 16r over 5. So the last little piece there was just algebra. The part that we're kind of pulling on from paper 2 work for this question is the similar triangles part at the start here. So you're looking at the fact that they're the same triangle, but just shrunk down or scaled up. So they've got all three the same angles, and it's in the same orientation, and you match your sides up, and you know that the ratio of the sides to each other stays the same. Okay, now it says find the volume of water in the cup in terms of r. Well, what you need to do is go to your log tables first and get the volume of a cone, and you start by writing that down for yourself and make sure you're getting those marks. So v is equal to 1/3 pi r squared h. I actually know h now is going to be 16r over 5, so I've got 1/3 pi r squared multiplied by 16r all over 5, and if I tidy that out, I'm going to have 16 over 15 pi r cubed, and we'll put in the units, it's volume, so it's millimeters cubed. The next one, it says find the rate at which the radius of the free surface of the water is decreasing. So what I want to know is what is the rate of the radius? Well, okay, I don't know, don't have a formula for radius and time, but that's what I'm really looking for here is dr dt. Okay, that's what I want. I'm going to say, what do I have? And if I go back up to the question, we did actually have a rate to begin with. If we go back, look, it's leaking at a constant rate of 8 millimeters cubed. So I actually know that. And if I think about what that is the change in volume with respect to time. And that is going to be minus 8 millimeters cubed per second. Okay, so what do I want? What do I have? And then remember, connection is the third thing you're looking for. So we're going to have to go, okay, I want dr dt. I have dv dt. What do I need to multiply that by to get this as my answer? Well, I would like to introduce a dr on the top, and I want to get rid of the dv in the end, so I'm going to say divide by dv. So this is what I'm looking for, really. That's what it's come down to. That's what I want to get. Can I find a connection between v and r? Yes, I can. We had it up here. So over here then, I'm going to have that v is equal to 16 over 15 pi r cubed. If I differentiate that with respect to r, I'm going to have, it's going to be 16 over 5 pi r squared. We're not done yet, so I should really be kind of keeping this as neat as I can. I can now start to piece it together. However, look at what I needed to fill in. dr dv, not dv dr. So how do I get that? Well, I'm just going to flip it. So dr dv is equal to 5 all over 16 pi r squared. Okay. And then I'm going to fill it in. And what I also know, because they've told me in the question, is I know what r is. They say, they don't say what r is actually. They say when the depth is 48. But I don't have this in terms of depth. I have it in terms of r. But I can figure out what the r is going to be because I do know the connection between the two. We knew that. So you can figure out what r needs to be. So let's fill in as much as we can here now. So dr dt is going to be equal to dv dt, which we had over here. That's what we were given in the question. So I'm going to have minus 8 because it's decreasing. So it's negative because it's decreasing, multiplied by dr dv, which is going to be this guy over here, which is 5 all over 16 pi r squared. Now I need to figure out what r is, so I'm going to do that. I'm going to say that it's 48 is equal to 16 r over 5. Do your algebra magic on that, and you're going to get that r is equal to, let me see what I wrote down earlier, it's equal to 15 millimeters. So now that you know that, you're going to chuck that right back in up there, and you're going to get a value for dr dt. So dr dt is equal to minus 8 multiplied by 5 all over 16 by pi by 15 squared, and have some bit of order. So I'm quite tired doing this. You can see the chaos on the page. So just make sure that, you know, if you do need to do a little bit of thinking, that you do it on a rough work page or maybe at the side, and you just go rough work and scribble out over here, and then have your calculation laid out linearly so it's easy to read. But when I do that out anyway, what I'm going to get out is minus 1 all over 90. Sorry, this should have been on the bottom the whole time. What am I doing? This should have been underneath the whole time. That should have gone down with the 16. Down here. There we go. So the whole thing should have got flipped upside down. The whole thing. The same here. The whole thing. That should have gone down underneath. So I moved that down underneath the fraction. Apologies. That's what I get for doing this so late and while I'm tired. But there you go. And this should be on the bottom as well. There we go. So you're going to get minus 1 all over 90, and then you've got your pi, and that's millimeters per second because it's the radius changing with the seconds. So just watch out for that. I made a mistake there where I forgot to put the pi r squared under the bottom. It all gets flipped upside down, not just the 16 over 5. But there we go. So I think that would be quite nice if it did come up, but just do what you can if it does, that type of question does pop up. The next one, hence find the rate at which the area of the free surface of the water is decreasing. So I now need to think about, okay, what do I know about area? They want to know the rate, so they want dA dt. So I want dA dt, so then I need to figure out, right, okay, what I have is dr dt, because I just figured that out. So I know dr dt, and I know that it's minus 1 all over 90 pi. So what's the connection between dA dt and dr dt? So dA dt is going to be dr dt multiplied by dA times dr. So I need to introduce a dA and I need to get rid of the drs. So what happens then is, I need to get dA dr. So first of all, I'm going to find the connection. So the connection is the surface of the water is a circle. So it's A is equal to pi r squared. If I get the derivative of that with respect to r, I'm going to get 2 pi r. And then I know what the radius is. We're talking about the same one in the last question. So I can fill that in, I think. So it says, hence find the rate. Yeah, so I know the radius is 15. So I know this is going to be 2 pi by 15, which is going to be 30. And then I'm going to fill that all in. And again, look, I'm not laying this out in the best way that I can. So just take your time with this. Tomorrow, if it does come up in the exams or whenever you see it, could be a paper 2 question or a paper 1 question, but you did ask for me to cover this. So let's finish it out. I'm going to have dA dt is equal to dr dt, which is going to be minus 1 all over 90 pi multiplied by dA dr, which is going to be 30. And if I do that out, I'm going to get minus 1/3 pi. Is what that's going to work out to be. No, it's not, because this is 30 pi and this is pi, and then that drops out and that drops out. And so we've just got minus 1/3, and that's going to be millimeters squared per second. That's it. So that's a nice tricky one if it does come up. But similar triangles, just one to look out for paper 1. Yes, it is a paper 2 kind of, or book 2 topic that we would have looked at, and it's something that we wouldn't have spent as much time on. You would have done it before in junior cycle, but that's the kind of question that they could ask in terms of similar triangles being used in an area and volume question. It's quite nice. It assesses lots of different skills. If it's something like that does come up, just take your time with it. Have a rough work column, have a scribble sheet to kind of jot down your ideas, and then lay out your calculations and try to have it a little bit more linear than what I had here. Learn from my mistakes and keep an eye on things like flipping the fractions so you just don't make an error on that. Okie doke, so best of luck.